All right, so here is another example of a situation that you could use these new non-right triangle laws for. So I'm going to walk you through this one as well. So this one says, ships A and B leave port at the same time and sail on straight paths making an angle of 60 degrees with each other. So I'm going to go ahead and I'm going to say, here's the port. So let me make a port. Let's just call that port. And it says the two boats leave the port at the same time and go on different straight line paths. So let's say this is path A. And let's say this is path B. Okay, so at the end of this orange path is going to be boat B, and at the end of this purple path is going to be boat A. And it's also telling us that the angle measured between is 60 degrees. Okay, then the question says, how far apart are the ships at the end of 1 hour? Okay, so that's very important, the time. So they're telling us 1 hour. So this could change depending on the scenario. So we know that the speed of ship A is 25 kilometers per hour. So this boat goes 25 kilometers per hour. And we know ship B goes 15 kilometers per hour. Well, the good news about this problem is if the boats only travel for 1 hour, then they go that distance. So if it's 25 kilometers per hour, this boat went 25 kilometers. And this boat would have gone 15 kilometers. Okay. Don't pay too much attention to the lengths of the purple and green segments. It's not drawn to scale. So this is longer than that one. And the question is, how far apart are the ships? So let's see. Here's the path from one ship to the other. So we want to know this. Distance between the ships. Distance between ships. Okay, so in this case, let's see. We definitely know more sides than angles. So that's a very good clue for the cosine law. And yeah, in this case, we only know one angle. So we're very limited in terms of using the sine law. So in this case, we're going to go with the cosine law. So let me write it up here. We're going to go with cosine law. And I'm going to put in parentheses, we know more sides. So that's a clue. Okay, so according to this, we would go, if this is the side that I want to calculate, this is the angle that I would reference. So I'm just going to call this D for distance. So I have D squared is equal to 25 squared plus 15 squared minus 2 times 25 times 15 cosine 60. Okay, I could very easily go into my calculator and just put all of that. Oh, sorry, not all of that. All of this, right? Because those are all numbers and all operations, so the calculator will do that very quickly. So I'm going to cheat real quick because I've already solved all of these. If I put that on the calculator, I will get... Oh, very nice. 475. So 475 units. And then notice that I want to get rid of that second power, so I'm going to take a square root. So square root. And if I do that, I will end up with the distance between the ships is 21.79, and what are my units? Kilometers. Okay, so 21.79 kilometers. So again, very pretty straightforward example, but you know, we did have to create the image and process and think which law applied in this case. So that's another example. All right, and we're going to continue on with these word problems. Here is a third example. Very, just like 2 sentences, but there's a lot of information in here. So this third one says, a plane flies 500 miles on a straight path. The plane then turns left 12 degrees on a new heading and goes another 300 miles. How far is the plane? So let me highlight this in a different color. How far is the plane from its original location? Okay, so I always think it's a good idea to map this out. So here is plane. I'm really bad at drawing. Oh, actually, I shouldn't do it that way. Well, here, plane. Okay, so first it says goes on a straight path. So straight path for 500 miles. 500 miles. Okay, check. The plane then turns left 12 degrees. So think about this. So here's like the path. Let me do it in a different color. So here's the path that the plane was headed on. I'll do it in this pinkish color. And let me change the... So the plane would have continued along this pinkish path, but it kind of diverted a little bit and went that way on that purple path. So I want you to see that the pink is the path it was headed on and the purple is where it turned. So this is the 12 degrees in here. 12 degrees. So it turned left 12 degrees. And then it went for another, it says 300 miles. And then the question is, how far is the plane from its original location? So here's the starting point. Here is ending point. There. That's probably good enough. Okay. So let me take this triangle out really quick so we can see it a little bit more clearly. So we have this, and we have this. Okay, so there's the triangle. So what are things we know? We know that the first path was 500 miles, so that's going to be helpful. We know the second path was 300 miles. And even though they didn't explicitly tell us, we also know this angle right here. And I'll show you how we know that. Okay, so over here, let me write this in that original pink color. Remember that here they told us that this was 12 degrees, right? But if you notice, this is actually one full line. And you should have learned in an earlier math class that when you have a straight line, there's a certain number of degrees. So we're looking at something like this. If this is 12 degrees, how much is that? And the answer is they have to add up to 180. So if we take 12, we get 168. So this pink angle that we're looking at here is 168. And we want to know how far it is from its original location. So that would be that. So this is also a very classic law of cosines example. We can see because we know 2 of the sides. So we know this side and we know this side. And we have the angle stuck in between. So this is what we would call a side angle side. Right, and since we know more sides, that leads us to the cosine law. So let's go ahead and set it up. So this will be x squared is equal to 300 squared plus 500 squared minus 2 times 300 times 500 cosine 168. And again, I'm going to cheat real quick because I've already worked out all of them. It looks like I get 633,44428. Where is it? 633,44428. And then we need to get rid of that second power. So, oops. So let's go ahead and take the square root. Let me make it a little bit bigger. So square root, and then we'll get x is approximately 795.89 miles. 795.89 miles. Which seems reasonable. You know, if you have 500 miles that way and then another 300, I mean, you know, it should be, give or take, it's in the right ballpark. So 795.89 miles.